Good afternoon. My name is Andrei Lopachenko, and I would like to give you an overview how generative AI and foundations models can be used in many different areas in smart cities. Let me share my screen in 1 second. Share screen, slideshow. So what's going on? There is a very dramatic leap of what type of models can be developed, and not only by power of the models, but how many organizations can develop them, and for what are different modalities. For example, I remember when I was working on maps 10 years, like 14 years ago, very few organizations like Apple and Google can develop very powerful traffic models. Now, many more organizations can do this, and it's about traffic foundation models, but there are many others. There are very deep and very powerful models in image recognition, video, image understanding, video understanding, text understanding, many other modalities. I will talk about them. So there is a huge dramatic leap in how generative AI and foundation models can empower not only big tech companies now, but many startups, smaller companies, and government organizations. There is a much bigger and wider spectrum of applications. Everyone talks now about text, about conversational, about chatbots, but there are models for deep understanding of voice and audio, for geospatial data, for traffic data, for sensor data, and there are different sensor data like building sensor data, but there are like personal sensor data from personal devices, satellite imagery, and many, many more modalities where foundation models apply and give a lot of power to build new type of use cases and applications. The democratization of these technologies means transformative smart city projects are now achievable without the need of billion-dollar investments, without the need of having huge data centers. Many more organizations, both private and public, can do them. And of course, there is a potential huge real-world impact, from enhancing public safety to urban planning to improving environmental sustainability and transportation, to using like sensor data in buildings, by like using imagery to understand what's going on. There are many more huge world impact potentials which can change and dramatically improve life and safety of many, many people around the world. Just some examples, like really, I think, fascinating in how powerful AI is now. There is a project from University of Bundeswehr Munich, and this project is creating 3D city maps from single radar image. So there is a SARS-2 radar imaging, which was done. And now they can create a very detailed 3D models of the cities just using one image, right? SARS imaging is pretty available now for like any city can get this from satellites and so on. But what is powerful, it's like only from one image. And of course, it can help to many like disaster response cases, many other cases. It's very impressive science achievement. Well, there is another big project by Google, European Center for Medium Range Weather Forecast, Johannes Kepler University, run corporation about better prediction of riverine flooding. And these projects now saves life by predicting, forecasting future flooding for 460 million people. Quality of like forecast is very much improved through these foundation models. It's done by these big companies, but also these models are available to be used by many other companies and public bodies. So why I'm talking about this, I have 2 decades of experience developing applications, mostly for consumer interfaces. I work in Google, Apple, Zillow, Walmart, eBay, designing large scale, not just AI applications, but large scales applications which serve billions of customers, which means like high performance AI stack. But I also had a lot of experience in geospatial AI, working on maps and like other leveraging location and traffic data. And that's why I believe it's my experience, especially like directly related to smart cities. I got my PhD in computer science from the University of Manchester, United Kingdom. So AI foundation models, what will be topic of our today? When we talk about generative AI, there are many different things there. We will focus on foundation models. Why they are? Because they have this power, which many teams needs, many companies or many public bodies needs, but they all have multimodality, which is needed. And they also produce this democratization, because you don't need to create many models for different things. You can create one model. So use one model from other organization to solve many of your problems. These models unlock new use cases, products, by deep understanding and interpretation of geospatial information, time series data, images, videos, edition, and many other types. And my aim of this talk is to highlight the importance of various modalities in smart cities and provide an overview of foundation technologies and opportunities they herald. Why foundation models? What's special about foundation models versus many other models which are developed across many years of AI? So foundation models, this new recent trend, but it's not just trend, it's really powerful trend which gives a lot of power to organizations to build use cases and products what they want. It's deep neural networks. To create this, train this deep neural network, you need of course a lot of data and very big computational power. But once you get this, you get a lot of capability power. They represent a significant shift from traditional, like one model per one task. You have one model which solves many different tasks, which is really important and really powerful, that enables them, like both within organization, or if one organization develops them, they can be used across many different organizations for their tasks, right? They can be further refined after the trend or fine-tuned to create enhanced performance for specific applications. They typically very large models, 7 billion, 14 billion more parameter size, sometimes smaller. You see some impressive models here, like 100 million parameters. And typical complexity requires they need some understanding how to serve them, how to train them. But once you do this, it gives you a lot of power to handle your cases. And certainly many startups, companies, public bodies working on smart cities can do this. Why we are talking about this? Smart cities encompass a broad range of challenges that necessitate profound intelligence and AI needs, applying across extensive and diverse data sets, right? We need very different data to serve smart cities just by nature of the problem. There are traffic data, there are urban imagery, weather conditions, electrical grids, sensor data, text data, voice data, video data, many other, right? And foundation models tailored to smart cities could level the playing field, enhancing AI use and enhancing AI capabilities across many different organizations, and led many organizations to focus on product use cases using these models for their needs. And kind of high-level overview, it's from Stanford Group on foundation models. It's a little bit focused on textual models, but the same principle applicable to all foundation models. You feed the model in training step with a lot of different data, but what's important, you get at the output a foundation model which serves many different tasks. Of course, it can be very different. Then here it's kind of high-level example, but in your case, it can be very different, but it's the same. You have one model serve many different tasks. Let's go into particular type of problems, like perhaps computer vision, images, video understanding will be one of the most foundational tasks for smart cities. And there is a very wide plethora of models. I'm just giving small example of them. They're very different needs. Like there are like models focused on image understanding, models on embedding representation of images, object extraction, text understanding in images depends, right? So it may be a very different task in smart cities. I will describe set of models and then I go kind of potential use cases, but many more use cases. There are models from OpenAI, Microsoft, Google DeepMind. There are many like Lava set of models and Strugbleed. Moondream is very interesting. It's very tiny model, like around 2 billion parameters, but it's good for edge deployments when you want not in data center, but in edge devices like phones and other so those are like image models. There are like special models like Prithvi is geospatial foundation models trained on satellite images by NASA and IBM, and it's useful to recognize you want to having a set of images of city, you want to recognize where flooding happens. So there are many other problems as foundation models can solve many different problems. But what's good, it's trained on satellite images and you can fine tune it and use it for many different city related problems. Beyond image understanding, there are many other computer vision generative AI models that can find applications in smart cities, like, for example, NERF models, diffusion models. You can imagine many tasks based on image generation, such that you can enable citizens to create various what they want and then city respond to them, right? Not only image understanding. Variable after encoders models, there are many different big set of computer vision models applicable to smart cities. And there are potentially many more use cases can be created, like, for example, deep understanding of locations using satellite and airplane imaging or drone imaging, also detection of meteorological phenomena or meteorological disasters, planning of maintenance work, right? Energy efficiency work. With drones, you can do a lot of imagery of particular locations and you can understand the state of the roofs and so on. There are many different ways how you can do image recognition. Computer vision models for vehicles, smart traffic management, driving safety, Computer vision models deployed on traffic and other companies, cameras, for deep understanding current state of transportation, pedestrian traffic, safety, emergency management, recognize emergency situations, advice and help to citizens. Like when people search for a house and I would like to make a house with a good solar panel, is this location good for me, right? Satellite imagery of these locations can help understand, is it a lot of sun, is this roof particular to the sun? And there are many different things can be done there and many other applications. Transportation foundation models. When I work in Google Maps and Apple, right, modeling of traffic was available very few organizations. Now it's much more available, and many more companies like want to manage fleet, do like of vehicles, want to do a smart routing of vehicles. They need to understand traffic deeply, and you can imagine how many smart cities opportunities in deep understanding of companies. 10 years ago, it was available to big tech companies. Now it's available to many more. There is a set of research you see there, like different labs and companies develop different types. There are not just one type, different types of transportation foundation models to model traffic. And they are different by their nature. And what they can use for traffic monitoring and prediction, optimization of traffic inside cities, smart parking management. I live both in San Francisco and Seattle previously, and I know like how hard to get a traffic like parking place, smart parking management. Deployments on edge, driver assistance with model deployments on the edge. You can use many different type of driver assistance used inside cities. Transportation planning, including public transportation, not only, of course, cars, disaster management, emergency response, and not only like visual data from cameras or from inside vehicles or from modeling traffic through sensor data, right? People also write about the traffic conditions. Text analysis of insights can be even sometimes more valuable than sensor observations or camera observations. Smart fleet management, of course, many companies need this, many cities need this, many other applications for transportation foundation models. Environmental, weather, and climate foundation models and other models typically developed by big companies or research institutions, but can be used for cities. Typically, like of course, where for the forecasts available publicly, right? But they kind of give you generic data, how many degrees, what's the pressure, and so on. As you know, like for example, aviation and marine use boating community use different type of forecasts because they need very different type of data, and of course, smart cities need other type of data beyond available through generic broadcast, right? So there are a lot of environmental weather climate foundation model appearing that can be actually like usable by cities. Extreme weather forecasting by Google GraphCast. Prithvi is kind of different. It's not just predicts weather, it's can detect weather patterns on the satellite imagery, but kind of it can be focused on detecting weather patterns, which can be useful. There are just purely atmospheric models like atmospheric dynamics, Feng-Fu, Climax, ForecastNet, and Pango Weather and other models. They're more focused on different type of like like weather prediction, but weather understanding, and also like ClimateBERT is more like text processing for weather. And there are different things you can do, right? One is forecasting, but another nowcasting to understand detail of what the current condition is, very small granular level of the city potentially, right? What's going on there. Data simulation, climate text analysis, weather pattern understanding, extreme weather prediction. There are many applications of foundation models designed for weather, climate, which can be very useful for smart cities. And of course, like NLP and SR models, the kind of big elephant in this room, right? Like everyone talks about them, but they have a huge application inside smart cities. Like, for example, understanding of speech. Again, was like if you would do this 3 years ago, typically you would go to cloud provider and you don't have any control. You cannot tune to your communication devices. You cannot tune to your particular, like maybe people in different locations, they have particularities how they talk, right? Now with a lot of open source models like Whisper, you can tune them. Of course, it's not so easy, but it's doable by many companies now. And now it's much more easy to have your SR than it was 3 years ago. It's very achievable by many companies, and potentially you can do it better than cloud providers. Speech generation, a lot of speech generation models which produce good high quality speech, right? If you want to create a different conversation devices such as talk to citizens, to customers, you can do it quite easily now. And of course, there is a big environment, like big abundance of NLP conversational models. Just for this topic, we can talk 10 hours. there are like thousands of them, and but there are like big trends, Llama 2, Mistral, some other open source models, commercial available, and there are of course open third party providers like Google, Amazon, OpenAI, Azure, here, Anthropic models. You can use them for your needs. And there is a huge variety of use cases for NLP and SR inside smart cities, like support of emergency response services. You can understand phone call. You can use textual understanding to produce much more information to assist to get that place as soon as possible, right? Like understanding location and so on. But there are, like, for example, a lot of research says that understanding audio per se can tell you about condition of the person. Like, for example, a heart attack can be diagnosed with some probability, many other, right? So emergency response in such cities. Accessibility features, certainly deploying different devices with capability to talk or visually interact with them. You can develop much smart accessibility features for people, right? You can imagine, like, if someone needs certain accessibility feature and this person can talk, you can just make sure that it's like turned on with a small conversational device and provide feedback to the person, and many more, right? You can give a lot of assistance to people who can communicate, for example, through voice, but they have visual impairment. Now you can create totally new applications quite easily by understanding their speech, by generating speech for them, by understanding text, which much more power and much more capability to produce very smart devices. Smart in vehicles, conversational and visual interfaces. Of course, like for citizens, interactive guidance and navigation, information assistance everywhere, safety and emergency information, distribution, civil engagement and community information, personalized interactions. Now you can create much smarter, much more friendly devices, help people with multiple different tasks inside smart cities. Call intelligence solutions to all call call centers and conversational-based services, so that if you want to understand conversations at scale, help them, improve them. Of course, there are questions with privacy preserving, how to make it problems to be solved, right? But like power of AI power is much has a lot of new capabilities there. And of course, you can imagine plethora of new opportunities within the context of smart cities. And there are many other families of foundations models which can be used for smart cities. For example, forecasting, right? Now there are a lot of models for time series understanding, and of course it can be used across many different applications, smart cities, and organizations can build much stronger time for forecasting for different tasks using time series foundation models. Of course, a lot of processing is based on documents, right? Many city organizations work on documents, and there are a lot of document understanding models which can process and help you to understand and automatize document processing for many different tasks. Of course, wearable sensor data, real, like my Garmin device. There are many other sensor devices focused on like daily life, on sport, on health, or like you can imagine, you can create very new services for people who use them. I can imagine plenty of use cases I have in my mind. Internet of Things sensor data, like for example, all these sensors deployed in buildings or bridges or many other city constructions, how to diagnose constructions, how to get more data, how to diagnose, get different things, foundation models for those. Text to image, right? A lot of potential use for different friendly services you can do with this. Reinforcement learning, robotics foundation models, very strong products, progress happening right now in robotics, which potentially enables a lot of new use cases for smart cities, right? And it was a short presentation, like just 20 minutes. So how to enable, how to use, how to enable, what is required from cities. Strong need in massive collections of publicly available data to develop more foundation models in images, video, sensor data, audio, transportation data. Kind of if cities put into making this data available, it will pay back by having more stronger AI capabilities to create stronger use cases and products for smart cities. And having foundation models will enable many new AI-based use cases and products for smart cities. So it was a brief overview. I believe these talks deserve maybe we need 5 hours to go deeply, because each of these families is very deep, very complicated, but huge set of capabilities. So it was high-level overview of what are models, what applications. Of course, there are many more models, there are many more applications. Thank you very much. It was great honor to present it.